Hi, my name is Alexi, and I'm the Director of Training here at Opto 22. In this screencast, we're going to take a brief look at the programming interface for PAC Control Basic. On the left-hand side of the screen is the strategy tree. From here, you can add, modify, or delete elements in your program. The first thing listed is the control engine. This is the SnapPAC hardware that will run your control program. Skipping subroutines for a moment, let's take a look at flowcharts, or charts for short. The idea is to divide your application up into specific tasks and create a flowchart to handle each task, or perhaps several smaller tasks. Your program, or as we call it, a control strategy, can start and stop tasks as your application requires. The SnapPAC R can run 16 charts at one time, and the SnapPAC S can run 32 charts simultaneously. It's easy to create a flowchart. Let's take a look at one. Here, we have an action block. On the outside, you'll put a descriptive name. On the inside, you can put one or more instructions. Double-click on the block, then click Add. At this point, you can select an instruction from the drop-down list. There are hundreds of selections here, or you can just type in the instruction name, or you can select it. Here, the commands are grouped by functionality. For example, all of the mathematical commands are grouped together. To turn on a digital point, I select the digital point group and the turn on command and click OK. To complete the command, you just fill in the blanks. By selecting your variables and I/O from a drop-down list, you can minimize or eliminate typing errors. You'll also notice the command is in plain English syntax. Turn on tank 1 pump. The second element in the flowchart is a decision block. Here, you're asking one or more questions. Is the pressure too high? Is the temperature too low? Like the action commands, the condition commands are in simple English format. Next up are connection lines, which determine the flow of logic. To draw a connection line, choose the Connect tool, click on the block you're going from, then click on the block you're going to. The arrows are drawn automatically so you can see the logic going from one block to the next. Those three constructs, action blocks, condition blocks, and connection lines, are all you really need to program with. But there are two more components you may wish to use. One is the continue block, which is similar to a go-to statement. Instead of drawing a connection line to a distant block, you can use a continue block to route the logic to another block in that chart. The final object is also optional, but extremely useful. This is an OptoScript block, which allows you to program in a scripting language. It is especially convenient for tasks such as calculating a mathematical formula, string handling, case statements, or conditional loops. For example, you might do a while loop or an if-then statement. The OptoScript editor comes with lots of useful tools, including cut, copy and paste, undo, and a test compiler. You can also insert any of the action or condition commands, as well as any variables from your tag database that you've already created. It's easy to access the online command help. Simply select a command, click on the command help button, and you can view the online command reference. Here you'll find important information about the command, examples of use, and related commands. Going back to subroutines, you'll see I've got a few listed here in the strategy tree. A subroutine is just another flowchart. Once you've included a subroutine in your strategy, it becomes a new command in your command set. You'll notice that PAC Control is very much a self-documenting program. You can put meaningful names on the outside of blocks, as well as additional comments using the text tool on the side of a flowchart. Additionally, names of variables and I/O points can and should be given meaningful descriptive names, such as tank 3 drain valve, which is much more intuitive. Speaking of variables, you can create as many of these as you need. You're limited only by the total memory in the control engine. You can create integers, floats, downtimers, uptimers, and strings. Advanced programmers might like to take advantage of the ability to use pointers. Another special variable type is a communication handle, which stores information needed to communicate with another device. For example, you might use a COM handle to transfer data to an FTP server, or to read in data from a serial barcode wand. Or you can create them on the fly as you program. Once created, these variables are accessible by any of the flowcharts in your strategy. Finally, we come to the most important component of your system, the I/O. Here, I already have several points configured, but it's easy to add more I/O to your program. Let's add a module to my existing I/O unit here in this empty slot. It's an analog input, and I'll select a 4-channel input voltage module. I can configure the 4 points on that module. Selecting one of them, I'll type a descriptive name. If I don't want to work in volts DC, that's not a problem. I can select the scalable option and type in new engineering units. I can type in any 2 points on the linear scale to reset the scaling, and now I'm using engineering units. Click OK, close, and now the I/O point has been added to the strategy tree. Thanks for watching my Intro to PAC Control Basics screencast. To learn more about Opto 22 software or to try it out for yourself, click on one of the links below. See you next time.